Hi Trigoners, this is Conditional Probability. Americans recycle more and more material through municipal waste collection each year. Use the information in the table based on a recent year. So this whole section is largely about tables, and the totals column and the totals row is going to be an important piece of information for you to add up. And sometimes they're going to have the column or row already there for you, and other times they won't, but it's going to be your first step when you're making these problems. In all the totals for us, and I think it's important to understand what each of those totals represents. So the entire table is about millions of tons of municipal waste collected in the United States in 1 year. So this total right here represents the total amount of recycled waste in millions of tons. This is the amount not recycled, and then this value here represents all together, so both recycled and not recycled. You can also look at it in the horizontal direction, so the amount of paper recycled, millions of tons, is 83.8 millions of tons, etc. And all of those get added up also to be the 217 millions of tons. Find the probability that a sample of recycled waste was paper. So the first thing when you read the question is that you have to be looking at recycled waste. So recycled waste says you're going to look in this column right here. So we have 60.7 millions of tons is our total, and of that, 34.9 is paper. As you'll see as I go through these problems, I'm not going to do any simplifying. I really just care about where the fraction comes from. Part C, find the probability that a sample of not recycled waste was paper. So that means you're going to have to look into a different column. So you're first looking at not recycled waste. And so that represents 156.3. And of that, 48.9 is paper. Part D, find the probability that a sample of paper was not recycled. So this time, you're looking at a sample of paper first. And you can look at this amount then, because this is your paper amount, so that's 83.8 for our denominator, and then you want it to be not recycled, so that's 48.9. And letter E, find the probability that a sample of paper was recycled, so 34.9 over 83.8. These will add up to 1, and it's because you're dealing with paper for both of them, and there's only two options. You either have not recycled or recycled paper, and so together they have to meet all of the tons for paper. I'm going to skip the now you try. If you'd like to try more practice problems on your own, you can find the answers on Canvas. I'm going to go to example number 2. Researchers asked shampoo users whether they apply shampoo directly to the head or indirectly using a hand. So how many people were surveyed? So this is one of those examples where they give you a table and they haven't put in totals for you, but you're going to want to do that for all of these values. So there are 50 people that are surveyed because that represents the ultimate total. You've got 50 going across and 50 going down. Find the probability that a person was male. So out of the 50 total participants, the male column is telling me, or male row is telling me that we have 20 people, so 20 out of 50. Find the probability that a person was female, so 30 over 50. Find the probability that a person put shampoo directly on their head, 8 out of 50. Find the probability that a male put shampoo into his hand first. So you are looking at this row right here because it specifically says a male. So there's 20 people that we have to consider. And of those people, we know that 18 of them put shampoo into their hand first. Letter F, find the probability that a person that put shampoo directly on the head is female. So this time you're looking at a column because we know that the person put shampoo directly onto their head. And of those people, 6 of them are female. So this is what we call conditional probability, these questions right here, where there's a condition that has to be met first. In letter E, the condition was the person was male. In letter F, it's that the person puts shampoo directly on their head. So there's some criteria that you have to meet first before you can even deal with any of the numbers. We'll skip example 3, and we'll move on to example 4. Use the table to find each probability regarding a university's distribution of degrees. Take a second and fill in the totals. All right, there are my totals. And in letter A, what is the probability a recipient is male? So there are 1,016 over 2,501. What is the probability a person has earned a bachelor's degree? So this time you're looking at the bachelor's degree row. So that's 1,323 over 2,501. What is the probability a person who has earned a master's degree is female? So this is where the conditional probability comes in, because the condition is earning a master's degree. So you're looking at this row. There are 567 people that have earned a master's degree, and the probability that they're female is 322 over the 567. Letter D, what is the probability of a person being female and earned a master's degree? So this is not conditional because it's really saying a very specific type of person. So this is a cell within the table. So female and master's degree is this place right here. So that'll be 322 over 2,501. I know that the words are subtle, but female and master's degree is a specific place, whereas there are several ways. In letter C, it's what's the probability a person who has earned a master's degree. You're looking at the entire row first. And that's actually reducing your population because you have a certain criteria to meet. So that's looking at master's degrees first. Letter E, what is the probability that a male participant has earned a bachelor's degree? So that is conditional as well because your criteria is male. So you're looking at this column first. There's 1,016 in your denominator because that's how many people are male, and then earning a bachelor's degree is 547. All right. So let's go back to parts A through E and give an abbreviated notation because these sentences are good, but sometimes we ask you to do problems where the notation is just a little faster. So in part A, the probability a recipient is male, perhaps we could have said this. Find P of M. Part B, the probability a person has earned a bachelor's degree. Find the probability of BD. What is the probability a person who has earned a master's degree is female? This is the notation for conditional probability. And we use a vertical bar, and it means given that or such that. So you read it as find the probability a person is female, because that's ultimately what we're trying to find, given that they have a master's degree. So I know that it's written second, but it's actually the first thing that we read, or first thing that we would consider when looking at the table. Letter D, the probability of a person being female and earned a master's degree, we could write it this way, the probability of female and master's degree, or you may see it with a different math notation as F intersect MD, like you guys saw in geometry or even earlier in this unit. And letter E, the probability that a male recipient has earned a bachelor's degree. We're back to the conditional probability, because ultimately we care about the bachelor's degree probability, but we have to meet a condition first, and that condition is the male person receives it. So again, this is given that, and the way we would read it is to say find the probability a person has earned a bachelor's degree given that they're male. Here is a formula that we use to solve questions, because sometimes the questions don't come with tables. The probability of an event, A, given B, is the probability of A and B, or you might even read it somewhere else as A intersect B, divided by the probability of B. So in my head, when I think of this and I try to remember, I just see that this and this have to be the same. So this denominator has to represent the entire probability of this event happening, and the numerator is both of those happening at exactly the same time. If you go back to this problem that we just saw, find the probability of a person being female given that they have earned a master's degree. We could do this as the probability of a female and master's degree all over the probability of having a master's degree, and you could go back to the table to find all of your values. So this is 322 over 2501 divided by the probability of getting a master's degree. So that would be 567 all over 2501 is 322 over 567. And that is exactly the same answer that we got right here. So all the math works out. It's just that sometimes you're not given tables to do the math. Sometimes you're given phrases like this. Number 5, 80% of an airline's flights depart on schedule. 72% of its flights depart and arrive on schedule. Find the probability that a flight that departs on time also arrives on time. So ultimately, we want to find the probability that the plane arrives on time, but there is a condition to meet first. And that is that the plane departs on time. So based on the formula that that I just gave to you, we need the probability that a plane arrives and departs on time, and then we divide it by the probability that the plane departs on time. And rereading the text, we have both of these values here. 80% of an airline's flights depart on schedule. 72% of its flights depart and arrive on schedule. So 90% of the time, a plane will arrive on time given that it departs on time. That's it for conditional probability.